Kirchhoff's circuit laws. First one is Kirchhoff's current law. It states that all current entering to a node is equal to all current exiting a node. That is, the sum of all current in a node is equal to 0. This law is conservation of charge. This is a node. Current I1, I2, I3 are entering to the node, and I4, I5, I6 are exiting this node. Then we can write sum of Ik equal to 0. That is I1 plus I2 plus I3. Since I4, I5, I6 are exiting the node, we can write minus I4 minus I5 minus I6 equal to 0. We take the current entering to node as positive and current exiting a node as negative. Then we can write I1 plus I2 plus I3 equal to I4 plus I5 plus I6. That is, all current entering a node equal to all current exiting a node. Consider this circuit. Here V1 and V2 are voltage sources. Here I1 is entering to this node, I2 is entering to this node, I3 is exiting this node. Then at this node A, we can write I1 plus I2 equal to I3. At node B, I3 is entering to the node and I1 is exiting, I2 is exiting. Then at B, we can write I3 equal to I1 plus I2. Second one is Kirchhoff Voltage Law, which is also called Kirchhoff second law. It states that algebraic sum of all voltages in a closed loop circuit must be equal to 0. That is, sum over k is equal to 1 and Vk equal to 0. Consider this circuit. Here V is the voltage source and R1, R2, R3 are resistors connected in series. I is the current through the loop. Then IR1 is the voltage drop across R1 and IR2 is the voltage drop across R2. Similarly, IR3 voltage drop across R3. Here we write as positive and voltage drops we can write as negative. Then V minus IR1 minus IR2 minus IR3 equal to 0. Let us try to solve one example. Here 20 and 30 volt are voltage sources, 2 ohm, 6 ohm and 6 ohm resistance are here. We have to find out I1, I2 and I3. We have to find out I1, I2 and I3. Now let's see this node A. By Kirchhoff current law, I1 plus I2 is equal to I3. We can write I1 plus I2 equal to I3. Now let us consider this closed loop 1. Here 20 volt is the voltage source, I1 is the current, then voltage drop here is 2I1 and voltage drop here is 6I3. Then we can write 20 volt equal to 2I1 plus 6I3. But we have I3 as I1 plus I2. But we have I3 equal to I1 plus I2. Then we can write 2I1 plus 6 I1 plus I2, which gives 20 volt equal to 8 I1 plus 6 I2. Consider this closed loop. Here 30 is the voltage source, 6 I2 and 6 I3 are voltage drops. Then we can write 30 equal to 6 I2 plus 6 I3. Similarly, we can write 6 I2 plus 6 I1 plus I2, which gives 30 volt equal to 6 I1 plus 12 I2. Now we have two equations and two variables, which is easily solvable. Now I will multiply this equation by 2, then I will get 40 volt equal to 16 I1 plus 12 I2. Just subtract, then I'll get minus 10 volt equal to minus 10 I1. That is I1 equal to 1 ampere. Now you can substitute I1 equal to 1 in any one of this equation and you can find out I2. I am substituting I1 equal to 1 in this equation, that will gives 30 volt equal to 6 into 1 plus 12 I2. I'll take this 6 to this side, that will give 24 equal to 12 I2 and I2 equal to 24 by 12, that is I2 equal to 2 amperes. We have I1 plus I2 equal to I3, then I'll substitute I1 and I2 in this equation, then I'll get I3 equal to 1 plus 2 equal to 3 amperes. We have I1 equal to 1 ampere, I2 equal to 2 amperes, I3 equal to 3 amperes. Let us check third loop. We have one more loop like this. In third loop, we have 20 volt and 30 volt connected reversely. Then I'll write 20 minus 30 volt equal to, voltage drop is here 2 I1. Here voltage drop is 6 I2, which is reverse direction. Then I'll write minus 6 I2. Let us put the value of I1 and I2 in this equation, which is equal to 2 into 1 minus 6 into 2, which is equal to minus 10.